Hello everyone, I am Surma Chaudhary. Today I will discuss preference over lotteries, which is a important topics of Advance Microeconomics course. Before that, I would like to thank all of you to come here for knowledge seek. And without any further delay, let's go to the video. First of all, we have to know what is preference and uncertainty, because these are very closely related with preference over lotteries. Uncertainty means when an outcome of an event is not known in advance, and then preference over lotteries means the way an individual rank his choices based on their desired outcome, desires, wants and needs. Preference over lotteries means how a person or chooses between uncertainties outcomes based on their risk attitude and expected utility. Now we can see simple lotteries. Here let A is the set of outcomes and L is the set of simple lotteries. Here we can say A contain A1 up to AN and LS contain P1 vector multiplication with A1 up to Pn vector multiplication with An. Here P greater than 0 means the probability will be greater than 0, and summation of Pi means the summation of all probability equal to 1. Here A equal vector multiplication vector of outcomes, and P means the vectors of probabilities. Vector multiplication means the element wise multiplication, and then we can see the graphical representation of simple lotteries. Here in x-axis we got point 1, 0, that means outcomes 1 will happen with certainty, and here in y-axis we got point 0, 1, which means outcome 2 will happen with certainty. And then we can see a three-dimensional graphical representation of simple lotteries, and also we have to know what is compound lotteries. Compound lotteries means a lotteries is whose price are themselves lotteries, means instead of receiving an outcomes directly outcomes, the winner first receive another lottery, and that second lottery then determine the final outcomes. And then reduction to a simple lottery, although this setup appears complex and every compound lottery to be reduced to a simple lottery that all the same final distribution of outcomes. Here for each outcome n equal 1 up to n, the probability of receiving that outcome in the reduced lottery is Pn equal alpha 1 Pn 1 and alpha 2 Pn 2 up to summation alpha k Pnk. Here Pnk the probability of outcome n from lottery Lk, and alpha k the probability of being assigned to a lottery Lk. Here we can see the graphical representation of reduced lottery, and then we have to know what is axiom. There are 6 axioms. Axioms helps us to comprehend how people make decision when things are uncertain, and this also describe logical conduct when making decision in face of uncertainty. First axiom say when we have two lotteries and we are indifferent between we have our preference will be indifferent between these two lotteries. Suppose I have two job, one job A and job B, and I am indifferent between these two job, such as I would prefer A over B, and sometimes I would prefer B over A. Then we can see transitivity axiom, which ensure consistency in preference. Like a decision maker prefers apples over bananas and bananas over cherries, and he also can prefers apples over cherries. And then continuity is that if an individual prefer for one lottery over another is not absolute, then there must be some intermediate probability p where they are indifferent between the two lotteries. Here we can see the mathematical notation of continuity, and then we can see a example of continuity as car trip. If a beautiful car trip is preferred to a staying home than mix of outcome L with sufficiently small but positive probability of death by a car is still preferred to L prime. Here we can see the monotonicity, which is fourth axiom. If two simple lotteries is potential odd, only the best and worst outcome, then that which are the best outcomes with higher probability is preferred. For example, probability p and pi belongs to a closed set from 0 to 1, and we get p vector multiplication with a1 comma 1 minus p vector multiplication with an get preferred to pi vector multiplication with an and a1 and 1 comma pi vector multiplication with an, if and only if p get preferred to pi. Here a1 is best possible outcome and an worst possible outcome, and pi and p is the probability of getting the best outcome. Then the fifth axiom is substitution. This axiom with the idea that if we are indifferent between two component of lottery, substituting one for another will not change our overall preference for lottery. Such as we have to we can see L and G where L contain P1 L by vector multiplication of L1 up to Pn vector multiplication of Ln, and G equal Pm1 vector multiplication of G1 up to Pn vector multiplication of Gn. Here L and G represent two different lotteries. Each lottery has n possible outcome. For lottery L, outcome L I occur with probability Pi. Similarly for lottery G, outcome Gi occurs with probability Pi, and if for every I Li indifferent to with Gi, then we must be indifferent between the entire lottery L and entire lottery G. And the last axiom is indifference axiom, which posit that our relative preference between two lotteries should not change if both are combined with a third unrelated lotteries in the same way, such as L preferred to L prime if and only if alpha L plus 1 minus alpha L double prime preferred to alpha L prime plus 1 minus alpha L double prime. Thank you all. Thank you for give your valuable time to me. Thanks.